Hey everybody, how you doing? Today we're going to cover some really cool things. We're going to cover ham radio, 3D printing, and build a multi-band vertical dipole, or fan dipole. Over the holiday I picked up an Android 3D Pro. It's a 3D printer. I've been busy making 3D parts for ham radio, so stay tuned. When I'm building antennas, you know you're going to have to tune that. So before I go out, I try to use the exact same equipment. So in this case, I'm going to use the AA Zoom 55. Today we're going to use a 50-foot piece of RG8X, and we're going to set the calibration plane at the end of that. So that way we can get the most accurate SWR at the feed point rather than where it connects to the radio. So here's one of the pieces I created using 3D printer. So this plate will be used as a base plate at the base of our pole. We have our connector here for our coax. This is where our ground radials go. You can see this is where they're all connected. 3 posts for the radiating elements. And you can see they're connected here as well. Another 3D printed piece that I created, my version of a shock cord hook connector. You know, these are pretty good. I like them. They're lightweight, they're small, they do their job, but wouldn't you rather make something yourself? Of course you would. So here I created this little piece here with a little bit more of a fortified hook. Your cap over the end of this, put your shock cord down in that slot, tuck anything extra down below here, and then close it up. And so now you got a secure shock cord hook. Another thing that I created, this piece is modeled from what's known as a resting Fifi hook and is often used in carabining and mountaineering. And the way this would be used is whatever end you're coming from, you loop it in through here, catch it on the hook, and then you have the beginning of a secure loop. Now that's not totally secure yet, we got to keep going. So you bring this over, create a bite, and then put your working end down here. Now that binds and that won't come loose. Another purpose for this is if you wanted to use some mechanical advantage here. Imagine this is hooked to maybe a cord coming off of a tree or a guy line that you're running. Then you pull on this to bring in your tension and then pinch this end. From that, and bring your rope in through the hole like that and bring it up over your hook, tighten it down, and in doing so you then create enough binding that it's not going to slip after you've tightened it up. Here's another example of combining ham radio and 3D printing. This is a common mode choke and a 4-to-1 Ballon transformer. I'm running copper-clad steel 20 gauge wire on a couple of 140-43 ferrite toroids, a BNC connector, and then the 3D printed part that's shaped like a kite winder, so you can wind whatever line, whatever wire you're using. I really like the 4-to-1 for an off-center fed dipole. So here's another example of ham radio and 3D printing. Pretty cool combination. Let's take a look at some of the equipment we're going to use today. I'm taking my radio in my backpack. We've got our Jackite pole. We have all our 3D printed parts. We have our wire. Went down to Home Depot and picked up some 16 gauge lamp wire. So this is 200 feet, so actually you're getting 500 feet, and it was about $50. I'm going to use this for the radiating portion, and I've got some clear lamp wire that I'm going to use for the radials. And so finally, After we get our antenna up and secure and all of our wires tuned, then we're going to make a couple of QSOs and finish off the day. So stay tuned. First piece here, our 31-foot fiberglass telescopic kite pole from Jackite. I got a number of pieces that we're going to use here, all of which, the majority of which, were part of the 3D printing that I built. Ham radio and 3D printing are like the perfect relationship. So we're going to put this antenna right here, take out our radials. And you remember I talked about this piece and all of these pieces that I created on 3D printing. I tapered the diameter of the center hole here so that it would fit nicely about the right place along the pole. And we can attach a guide wire if necessary. A couple of tent stakes here. You can use these little straps here to hold this base plate down. Same with this one here. Use our butt cap. Trusty bowl in here. More of these. One more of our guy lines. Going to use our modified Fifi hook here. Okay, so let's connect some cable. Here's a 46 one. Here's a 17-foot. And another 17. So let's go with the 17. And then you're going to need our shock cord and one of our little shock cord adapters here. Okay, so I'm going to go on this outer side. I'll go ahead and connect this one up right here. Let's go right here. Tie a little knot down here. Pretty simple. I'll leave that there. Let's get some electrical tape to hold it down to connect our antenna up. Okay, so that is our first line, and the next one we want to do is the 80 meter or 40 meters. So let's get that one connected. This one's off the top again. So run that one right through there. I think we're ready to put something in the air. Alright, so now we got our base plate up. The first fatality, so that little post there that I made sheared right off. Could be that what we need to do is just put a metal post with a locking nut on that. Okay, so that doesn't work. Note to self. That is without any radials. 20 meters, quarter length as well, and the 40 meter is way too long, I know that. Okay, I'm using 14 gauge lamp wire that I got from Home Depot. Two 15-foot lengths and two 24-foot lengths times 4, so 16 total. The downside of this is losing these things in the grass. You just got to carry a bunch of them, because I've already lost one since I've been out here. Okay, let's check to see how we're doing with just the 8 radials. Getting better. The 14 is definitely high, and 40 meters is coming down, interestingly enough. Let's add our next radials. I still have not cut anything yet, but I've added all the radials. Let's see what that looks like. Okay, so it didn't change a whole lot, so let's do some cutting. Let's go with 20 meters first. I know my 20 meter line was at 17 feet, probably be at 16. So let me just take whack off of that, see if we made any improvements. Okay, we're still high on 20 meters. So I cut off quite a bit of wire. I cut off that much. Maybe not, maybe like 14. So that would be in the almost 16-foot length. And check out what the meter says. So you can see I'm certainly long on the 20 or on the 40 meter, but I knew that. And on 20 meters, we're looking pretty good. And you could definitely tune in any of those. So I'm happy so far. Let's see, 1484. And I'm blowing in the wind there, but ooh. I say we try to get on the air. Okay, let's see if we can reach somebody. CQ, 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 W0KNI, Whiskey 0 Kilo November India, calling CQ any station, CQ any station.
You sound good in Orange County, KF6YIJ.
Roger, Roger, KF6YNK.
Yankee India Juliet. The old miss is up from us about 2K up. Do you want to move down to 287?
Roger that.
KY5.
All right, let's try to get another one. Is this frequency clear? Is this frequency clear? W0KNI. Whiskey 0 Kilo November India calling CQ, CQ, CQ. CQ any station, Whiskey 0 Kilo November India out of Oregon, calling CQ out of Oregon.
Kilo X-ray 7 Tango Lima. Kilo X-ray 7 Tango Lima.
Kilo X-ray 7.
Roger, can we do that? 280. Dropped over there. It is Kilo X-ray 7 Tango Lima. Over.
Roger, Roger. You are a 5-8 in Oregon on a multiband vertical. You were contact number 2 today. I'm working on this out in a park, trying to get everything tuned up. Where are you located?
You are coming here at about 5-5. I am in Tucson, Arizona. Tucson, Arizona. Over.
So thanks for making it this far. If you enjoyed what you watched, give me the thumbs up. If you want to see more of my content, hit the subscribe button and also alerts so that way you know when I post something new. I want to cover a couple of things to kind of recap, kind of sum up what we've done here. There were a couple of problems we had in the field. One of my designs, for example, this butt cap, the center post here, which was connected to this piece, snapped off right away. So I'm going to forgo this with the 3D post using PLA material, and I'll probably just use a steel bolt and secure it with a nut. The next thing is here are the antenna stabilizer dividers, whatever you want to call them. There are 3 of these that go up the Jackite pole, and I think what I'm going to do is make these so that the holes where the radiating element goes are at least 6 inches apart. So we're just going to expand these, and right now I have it tapered, so as you go up, the wires get closer together, and I think we're probably better off keeping them consistently 6 inches apart if at all possible. The next thing for improvement, and again, here's a perfect reason why 3D printing and ham radio are such a great fit. So this guy right here, I found it kind of difficult maneuvering around with these wing nuts. And it would be better if this was extended out so that I could run my radials from the same location, but have the wing nut clear out here and out of the middle here. So I think what we'll do is, I think we'll extrude this design and then reprint it and see how that goes. Problem with the 20 meter SWR. I'm hoping that the 6-inch distance is going to solve that. We'll see. Check back. Contacts. So I made only 2 QSOs on 20 meters, and you saw how bad the SWR 20 meters was moving around and jumping around. I tried 40 meters, but the band wasn't very good. It was kind of noisy, but I didn't hear a lot of traffic. The SWR on that frequency was really, really good. Costs. So let's sum this up. But basically, there are 7 main categories for this whole setup. Jackite 31-foot pole, which was $90. All the radio wires cost about $25. The antenna wire, probably $15. I didn't use a lot of that. Shock cord, another $15. The 3D printed parts, that's a tough one because you need the printer and you need the filament. I'm using PLA type filament, but the cost of that is going to go down for the more items that you print. So I'm just going to put $25 in there for the whole spool of PLA material, which would print out dozens of pieces that you saw I used today. The chartreuse paracord, I probably used $5 of that. And then finally miscellaneous hardware like the stainless steel wing nuts and the bolts and nuts, everything that you needed to wire everything up, the coax connectors. I put $15 down for that. So the whole thing came to about $195, which is very comparable if you were to buy a kit somewhere. For example, the DX Commander, which creates an amazing kit, ready to go, has all the pieces you need, has lots of testing behind it, and seems to do a great job out in the field, costs about that much, maybe a little more depending on what model you get. But the cool thing about what we did is we built our own. We designed it from scratch, we ordered the parts, put them together, went out in the field, and made it work, and made 2 contacts. So I hope you enjoyed this video. Don't forget to like and subscribe, and I hope to hear you on the air. W0KNI clear.